Hello, everybody. We're going to go ahead and work on that intro to mole conversions together. I think I'm going to shut off my video because it's just going to get in our way. I think I'm going to fold my Chromebook over so that I can write on it a little bit more easily. So let's see if I can make my image go away. So there we go. Okay, so let's go ahead and see what we can do to solve this. I'm going to go ahead and do that first practice conversion. You just move ahead to whichever problem you need help with. I'll do the whole worksheet. And if you want to sit and listen to me do the whole worksheet, well, that sounds awful to me, but you can. Otherwise, skip ahead to the ones that you need help with. So I'm going to go ahead and do the very first one that was the practice. I'm going to fold my Chromebook over. So give me just a second so I can work on it better. There we go. Okay, so I see I have 250 bubseds. So I want to put bubseds on the bottom because I want that unit to cancel out. So I'm going to write 49 bubseds on the bottom, and that goes with 1 plemic, and I'm going to put that on the top. So now my units bubseds cancel out, and now I'm in the unit plemics. So now I want to cancel out plemics. So I do 32 plemics on the bottom, and that goes with 12 mugattis. Yes, these are entirely made up words. I made mugattis. Yep. I made a program on the internet. I found a program on the internet that would make up words for me. All right, now the units plemics have canceled out, and now I want to get rid of my mugattis. So 29 mugattis for every 1 opacat, and that's what I was trying to convert to because I wanted an opacat. So the mugattis have canceled out, and the unit that I'm in is opacats. Now I have to multiply everything that's on the top. So I'm going to multiply, let me change colors here quickly. I'm going to multiply 250 times 1 times 12 times 1, and I need to do that in my calculator here really quickly. So 250 times, I'm just going to do times 12, divided by, and then everything that's on the bottom. So 49, 32, and 29. And super important that we learn this right away. These have to be in parentheses. If you forget to add and close your parentheses, you will get the wrong answer. So across the top, it was 3,000, and now I'm going to do divided by, and in parentheses, I'm going to do 49 times 32 times 29, close parentheses, and my final answer is 0.066 opacats. That would be my final answer. Okay, so that's just showing you how you need to cross off units. And so you always put the unit that you're trying to get rid of on the bottom of the next conversion factor. This is a conversion factor. This is a conversion factor. This is a conversion factor. Okay, let's try some real problems now, not some fake stuff. It says how many grams are there in 0.35 moles of phosphorus? So I always write down what they give me. Oops, sorry, I already started out wrong. 0.35 moles of phosphorus. MOL is the abbreviation for mole. I draw my conversion factor, and even though I don't know exactly what I'm doing, I'm going to put mole on the bottom because I want that unit to cancel out. If I look at my mole roadmap, I can see that when I put moles on the bottom, it's always 1 mole, and I'm trying to get to, they want me to get to grams, so I'm going to write grams over here. And so if I want my unit to end in grams, I better have grams on top. So for grams, that's where we look at our periodic table and we look at the atomic mass. So I'm pulling out my periodic table. You can hear me doing that. And the atomic mass or the mass of 1 mole of phosphorus is 30.974. And the units moles cancel out, and I'm left with the unit grams, which is the right answer. So now I just multiply everything across and divide by everything on the bottom. Well, there's only 1 on the bottom, so I don't have a lot of dividing to do. So 0.35 times 30.974, and your answer can just have 2 decimal points, and I'm happy with that. So in this case, the answer is 10.84, and we are done. All right, next, let's switch colors. Let's have a whole rainbow of colors. How many moles are in a 255 gram sample? So let's write down what they give me. 255 grams of Na2CO3. And then I'm going to draw my conversion factor. And this is a 1-step, just going from grams to moles. Why did I write mole with an E? I don't have any idea. But what unit needs to go on the bottom? Well, grams needs to go on the bottom so that I can get rid of it, and mole needs to be on the top. Whenever you're using a conversion factor, it's always 1 mole. It's never a different number. This is the conversion factor. It's always 1 mole. The grams is always the grams that's found on the periodic table. And to save myself time on this video, I added up everything previously so that I would know what numbers to write here. So for the Na2CO3, I added 2 sodiums, 1 hydrogen, and 3 oxygens, and I got a mass of 105.99. I think I wrote that down right. So for every 105.99 grams, there is 1 mole of sodium bicarbonate. So now I'm going to cross off my units. I'm left with moles, and now I just need to multiply. 255 times 1 is 255, and then divide by what's on the bottom. So 255 divided by 105.99, and I get the answer of 2.4, and that actually rounds up to 2.41 moles, and that is my answer, 2.41 moles of, really, you should do this, CO3, sodium carbonate, not bicarbonate. I think I said bicarbonate. It's sodium carbonate. All right, let's switch colors. Let's keep going. Let's try blue. This time I have NH3 molecules, and I want to know how many moles. So now I'm starting at the top of my mole roadmap. I always write down, I don't look at the mole roadmap, to be clear. I think the mole roadmap is sometimes a problem. For people, it ends up being such a crutch that they can't do anything without it. So I write down what they gave me. They gave me molecules of NH3, and I draw a line. All they want is moles, so that's a 1 step going from the top of the mole roadmap to the middle. So I'm looking for the unit of moles. So I know that, molecules, I can keep writing, I guess. Molecules is going to be on the bottom, and moles is going to be on the top. For this conversion factor, it's always 1 mole. It's never any other number than 1. But for molecules, that's Avogadro's number. So that's 6.02 times 10 to the 23rd. So now to multiply this is a place where people are going to make a mistake. So let me make it stand out. You must put that in parentheses, or you will get the wrong answer. So I'm going to do 8.7. I'm typing it into my calculator, 8.7 times 10. And for me, it's y to the x, 22. And now I'm going to divide it by parentheses, 6.02 times 10 to the 23rd, close parentheses, and then I hit equals, or some of you hit return. And I get for an answer 0.1445, blah, blah, blah. So to 2 decimals, that would be 0.14. And that is my answer. And that's moles of NH3, really. I keep forgetting to do that. Okay, moving on to the 25th, molecules of calcium phosphate. All right, so there's a couple steps that we need to do, and it says what is the mass. So we're going from molecules to grams in this case, so that's a 2-step problem. It says mass is measured in grams. First, figure out the formula for calcium phosphate by crossing the charges. So calcium is a +2, and phosphate is a -3. Phosphate is PO4, and it's a -3. So if I were going to write that out, it would be Ca +2 and then PO4 with a -3. So I'm going to cross my charges. So I put a 2 down there and I put a 3 here. And now I'm going to erase those pluses because they're not supposed to really be there, the plus or minus. That's not supposed to be there. Let's see if I can make it go away. Did I make it go away? Try it. There. And that's my correct formula. Now, why did I have to calculate that correct formula? Because I need to calculate the mass, and so that totally matters. So I'm going to do 3 calciums plus 2 phosphoruses plus 8 oxygens. So I already did that, and I calculated the mass of that previously. So now I'm going to set up the whole. Problem. So what they give me is 9.5 times 10 to the 25th molecules. I can't spell. And it's a 2-step problem, so I'm going to give myself 2 conversion factors equals, and I'm converting all the way into grams of Ca3PO4 oops, 2. I didn't do that very well. Okay, so I know molecules has to go on the bottom, and whenever I have molecules on the bottom, it's going to be 1 mole on top. If you're not sure, look at your mole roadmap. And when it's molecules, it's always 6.02 times 10 to the 23rd. Ooh, that's going to require parentheses. Now my molecules have canceled off. I'm now in the unit moles, so I want 1 mole on the bottom. So moles cancels out, and I'm trying to get to grams, so I must need grams up here. So the question always is, how many grams? Where do we get that? And that's from adding up the mass of those elements right there. So the mass for this one is, I already did it, 310.18. I added up everything from my periodic table. Now I need to do the math. I'm going to do 9.5 times 10 to the 20, what was that, 25th? I can't read my own handwriting. 25th times 310, so give me a second to do that. 9.5 times 10 to the 25th times 1 times 310.18. And then I'm going to divide it by, super important, make sure that you have put parentheses. You can put parentheses here if you want, but no matter what, the whole bottom part of it has to be in parentheses. So divided by, and I'm doing parentheses, 6.02 times 10 to the 23rd times 1 if you want, close parentheses, equals. And I got a big number. I got 48,948.67 if we're rounding off to 2 decimals at the end. Can you read my handwriting, folks? There we go. That's the end of that one. Next. What color should we choose for this one? I'm not a big fan of the other colors, so let's go back to red. Yeah, the red is where we were anyway. Okay, what is the mass of 12.5 moles of carbon monoxide? So 12.5 moles of CO, and going from moles to grams is just one step. So we want it in we want grams. So we're going to do 1 mole. And then the mass of carbon monoxide is 28.01 grams. And so now we multiply it out, 12.5 times 28.01. It's like we got easier. This was an easier problem, is 350.1, and I'm rounding the 2 to a 3 grams of CO. And we're done. Okay, now I need to get to the next page and I forget how to do it. Oh, there we go. I got the next page. Now let's see if I can make it all big. Question number 7 is what we start with. So let's go to purple. How many moles of PCl5 are in a 1 kilogram sample? Remember that 1 kilogram equals 1,000 grams. Set up another conversion factor like you have been doing, but this one is for grams to kilograms. Which unit goes on top of the conversion factor? It depends. Make the units cancel. So let's start out. How many moles of PCl5 are there in a 1.5 kilogram sample? So what they gave me was 1.5 kilograms. I want to get rid of kilograms and put it into grams. So what unit goes on the bottom? Kilograms. In this case, 1 kilogram. This is the factor. This is the conversion factor for every 1,000 grams. Now my kilograms have canceled out. Woohoo! Now I'm in grams, and now I know how to do the rest of this. Now I'm converting from grams to moles. So I want grams on the bottom and moles on the top. And when we do it, it's always 1 mole. And then grams is the mass from the periodic table. So for PCl5, it's 1 phosphorus and 5 chlorines. So I already did that, and it's 208. I already added them all up, 0.22. And that's going to give me those grams are going to cancel out, and my unit that's left is moles. And so I'm going to put that right there. So I'm going to do 1.5 times 1,000. I'm going to do that right now. 1.5 times 1,000 times 1, good enough, equals divided by 1 times 208.22 equals 7.20. 7.20 moles of PCl5. That is my answer. All right, moving on. A balloon contains 7.3 times 10 to the 24th helium atoms. So 7.3 times 10 to the 24th atoms of helium. So now the question is how many moles is that? Just a one-step problem, folks. So I'm going to put atoms at the bottom and 1 mole on the top. Atoms will cancel out. How do I know how many atoms? Well, that's Avogadro's number, 6.02 times 10 to the 23rd. If you're not sure where I got that, look at your mole roadmap. I try to avoid my mole roadmap because I think it's a crutch that's not very helpful once we get good at this. Okay, so moles of helium is my unit at the end. So I'm going to do 7.3 times 10 to the 24th, right? Times 10 to the, oh crap, I did it wrong. Hold on, I just want to check my work. Yeah, 10 to the 24th. So 7.3 times 10 to the 24th, and then divided by, super important. I got to say it the same way every time. Put this in parentheses or it will be wrong. Okay, so divided by parentheses, 6.02 times 10 to the 23rd, close parentheses, equals, and my answer is 12.12. Nope, rounded off would be 1.3, and that is my final answer. Let me know if you have any questions. Next, let's try a greenie. A teaspoon of sugar, which is sucrose, has a mass of 8 grams. So that's what they're giving us, 8.0 grams of sucrose. How many sucrose molecules are in this sample? Now, is that a 1 or a 2-step problem? Well, that's a 2-step problem. We're going from grams to moles, and then we're going to go from moles to molecules. So I'm going to write molecules over here, molecules of sucrose. Okay, so we want grams to get canceled out. So we're going to put grams on the bottom, and that conversion is always with 1 mole. Over here, I'm going to write 1 mole on the bottom, so the moles cancel out. And that goes with molecules, and that's always 6.02 times 10 to the 23rd molecules. And then the question is how many grams? Well, that's the one I have to add up, and this one's annoying to add up. 12 carbons, 22 hydrogens, and 11 oxygens. I did it already for you. You're welcome. 342.45 grams. So now we multiply everything across the top. So 8 times 6.02. I could say 8 times 1 times 6.02 times 10 to the 23rd divided by, and it would be 342.45 times 1, but we could just do 342.45. And the answer is 1.4, and I'm going to round it to 1.41 times 10 to the 22nd. And does that answer make sense? Should I have a really big answer when I'm doing molecules or atoms? And the answer is, you guys, let's switch colors. Let's try back up to red. A sample of copper 2 carbonate. Well, we better figure out what copper 2 carbonate is. I might have to erase it. But let's just do it here for the moment. So copper 2 is a +2, and carbonate is a CO3 that's a -2. If we cross the charges, the 2 and the 2 cancel each other out. So it's just Cu, CO3. So now I'm going to add all of those up to get my mass. So it says we have a sample that has this mass, and we want to know how many moles. That's just a 1-step problem. I'm going to erase this so I have a little bit more space, if you don't mind. So let me erase that. There we go. And let's go ahead and keep writing. Okay, so they give us 13.1 grams. And then we do 1 conversion factor, and we want it in moles. So it's just a single-step problem for moles of copper carbonate. Okay, so we put grams on the bottom and always 1 mole opposite grams. And so the grams, when I added them all up, I had to add a carbon, a copper, a carbon, and 3 oxygens. And it looks like that mass was 123.55. The grams cancel out, and I'm left with the unit moles. So I do 13.1 times 1, we don't need to, divided by 123.55, and I get the answer 0.106. So we said we'll do 2 decimals, so that would be 0.11 if I'm going to round it off. 0.11, and that is my answer right there. Okay, last one, ladies and gentlemen. Magnesium combines with fluorine to form MgF2. Suppose you had a 150 gram sample of this compound. I'm going to write it down, 150 grams of MgF2. How many fluorine atoms are present? Okay, so we're going from grams to atoms. So that's going to be a two-step conversion. And then there's one more issue. There are 2 fluorine atoms for each molecule. So give me a second and we'll get to this. So to get rid of grams, we're going to put grams on the bottom, and that's always paired with 1 mole. So the grams of MgF2, we have to add them up, 1 magnesium and 2 fluorines, and I already did that, is 62.31. So now my grams cancel, and I need to put moles on the bottom to get them to cancel. And this time I want molecules on top. So molecules is Avogadro's number, 6.02 times 10 to the 23rd. Now I'm not done, so let me just do the math and then we'll show you one more step. So working across the top, 150 times 1 times 6.02 times 10 to the 23rd. And now I'm going to divide it by 62.31 times 1, whatever, it doesn't matter, equals, and that gives me 1.45, I'm rounding, times 10 to the 24th, times 10 to the 24th. I hope I did that right. 1.45 times 10 to the 24th. And that's molecules, I'm having trouble spelling, of MgF2. However, for each molecule of MgF2, there are 2 fluorines. So to finish this one up, we have to multiply the whole thing by 2. So 1.45 times 10 to the 24th. So I'm just going to, on my calculator, I still have that number pulled up. So I'm just going to do times 2. And we get 2.89, actually, if I rounded it all correctly, it would be 2.90 times 10 to the 24th atoms of fluorine, And that would be my answer. How many fluorine atoms? Okay, ladies and gentlemen, that's it. Let me know if you have any questions. Have a great day.